right, so we had the chance to learn a little bit about the Delaware water and the salinity of it. When we say a fancy word like salinity, we're just talking about the amount of salt that's in the water. If it has a lot of salt or if there's a little bit of salt, right? If it has a lot of salt, then it's considered salt water. If there's a little bit of salt or barely any, that's fresh water, and that's the water that we drink. What we learned earlier this week is that only 0.5% of the water available on Earth is fresh water. That's all the water that we have that we can drink, and that's all that's fresh water, which is unfortunate. All the rest of the water on Earth is either in glaciers where we can't access it, or it is salt water. All right. So it looks like we're about to hop back into our adventure. Let's see where it leads us.
Hey everyone! Hey! How is everybody doing so far? I know it's the morning. I know some of you are like, oh, it's the morning. Take stretch. So everybody's doing good?
Have fun.
Yeah. Everybody doing good? It's okay to unmute. I know it's the morning.
It's okay to type in the chat as well for those who don't want to talk. Or at least show a thumbs up.
Yeah, big thumbs up. Good. All right. I understand it's the morning. Sometimes I get a little, so I'll be like, oh, morning. But it's okay. We're gonna have a nice productive day. So, as you know, earlier we had Zaharia, who was the scientist, the hydrologist, and she kind of talked about the spells. I heard a little bit about the Delaware River, and a little bit about nitrates, and
salinity.
yeah, she did talk about she did talk about salinity and also water quality. So let's dive a little bit more into those types of topics. So,
what is water quality?
Yeah, that is a good question. What is water quality? Like, you got water and then you got quality, which means how good or bad something is.
How good the water is, how bad the water is.
Yeah, so that's basically what water quality is. It's basically in the name, water quality. We're basically testing the water. You know, there's these scientists who come out into the real world, and you see like the Delaware River, they come out into different rivers, lakes, the ocean, definitely a lot of oceans, ponds, and what they do is they run a little test to see how good is this water? Is it good enough that a lot of fish are thriving through it, a lot of plants are benefit from it?
It's healthy for everyone else,
Yep.
for it to be out there or not.
Yep. So
there's a lot of questions to this water quality testing,
especially
for out in our world.
Yep, and it is very important because little to the fact that actually the water that you see behind here, it's actually also our drinking water, but it's filtered. Yeah, it is. It's our drinking water. The lake, the river that you see back here, it's actually our drinking water. But you like,
it looks so dirty. Like, how are we drinking this?
I know, right?
You guys want to know how we're drinking this? Like, I have no idea.
Does anybody want to take a guess how this river can turn into drinking water? Anybody want to take a guess?
Very simple. You can type in the chat as well.
How about you, Bruno or Brian? Do you want to take a guess of how the water is kind of turned into clean water?
What do we have to do to make the water clean?
Any guesses? No? It's okay. So how it is actually it goes through a whole filter system. So it actually, like, people come in, they take some samples, so they actually go into these pipes, and then you see pipes underneath your sinks, and probably pipes that's going down in your bathroom or anywhere in your house. And a pipe takes up all that usable water, and it gets flushed all the way down into the filter system or company that they help filter the water from the dirty and nasty water, and then they make it into this clean water by a process. And then what that does is it goes back into the pipes, into like these water towers that you see, like these big gigantic water towers that you may see when you're driving out into the car. And then that water tower stores up all the clean water. But what happens is they take the water from the rivers, it goes into the pipes, into the cleaning system, and then it goes back up into the place, nice and fresh, into our homes, and then the cycle goes all around again. So that's how we
It's
get
a long
clean
process.
water. Yep.
It's a very long process. But I mean, we do need clean water, like we talked about Monday. All of us use a lot of water, especially humans, animals, everyone.
Yep. And speaking of water, I know Zahari and scientists mentioned salinity. So what is salinity? I know that's a big word. You're like, oh my goodness, what does that mean? Well, salinity is actually just salt. It's basically how much salt is in the water, or in any different types of water, like fresh water, brackish water, and salt water. So I'll give you an example, like freshwater, brackish water. What is actually freshwater, which is a river? They actually have less than 1% of freshwater, or PPT, which means parts per thousand. That's a lot.
Yeah.
Parts per thousand, that's a lot of salt. Like thousands. We're not talking about like one little tiny grain of salt. We're talking about thousands, probably like truckloads full of salt. That's how much salt we're talking about. Oh, that don't even get me started about the ocean. Guess how much? What do you believe? Thousand? So you think of that. It's actually 35 ppm, 35 parts per thousand of salt. That's a boatload of salt.
Very unhealthy for us, very unhealthy.
Well, it's not, it may seem unhealthy for us. That's why people tell us do not drink ocean water, because it has all that salt. And you can imagine if we drink that water, instantly our body's gonna react to it in a very bad way. Might get sick. But for the fishes and for the marine life in there, it's actually helping them, because a lot of them rely on the salt to, like, in their habitats to swim, to get their food, their nutrients. So that's also really good for them.
Right, yeah, but at the same time, it doesn't wait for us to like.
Yeah, we can't drink salt water. No, we definitely can't drink salt water. That's the no-go. Oh, wait, this was another one that Zahari mentioned. Nitrates. Nitrates. So what is nitrate? If you think of nitrates, it's like this little red and blue type of chemical compound, actually, that is actually it's actually nitrogen mixed with oxygen. So you have this nitrogen chemical, and then you have this oxygen chemical, and then they come together, they mix all together, mix, and they turn into nitrate. And what that does is it helps provides, as Nai earlier, how she came and she talked about how she does help provide nutrients for the plants. And also, not only nutrients, but she discussed if she gives too much nutrients, she makes this stuff called algae bloom, which is really, really really bad. So what algae bloom does is, I know how many of y'all saw Nemo? Yeah, you saw Nemo? Everyone saw Nemo? I don't know if you all remember the scene where you saw like all whole green stuff on the tank and it was covered with it. That's actually algae bloom. That's really called algae bloom. And what that stuff does is it's filled up with all these nitrates, and then it's blooming out these plants. And what it does is the algae bloom, it's literally sucking up all the oxygen from the water, from those animals who's living in that environment. And over time, as the algae continues to grow and covers everything, it's going to take up all the oxygen until there's nothing left in the tank, which means it's kind of bad for the animal, because it's slowly not getting enough oxygen in the water. Yeah, that's why you saw all of them was just covered in green stuff. It's kind of icky, and that's why they got it to be clean. So that's also some facts about, this type of water quality, nitrates, and salinity. So that's kind of cool. Yeah, it really is kind of cool. So I think there's something up coming up, right?
Yeah, it's a fun thing.
Yeah, so we talked about nitrates, we talked about salinity, and we talked about what freshwater is and how they actually clean it. You think they're ready for this activity? I don't think they're ready. You think they're ready?
Maybe we could.
Well,
You'll find out.
Well, tune into our next activity because it's going to be so cool. Let's go into it. Hello, everyone, and we're back into this super duper awesome activity. All right. So I know you might see clear screen right now, but actually we got all this cool supplies on the table right now. because we're actually going to be testing some samples of water. Okay, we have our filtered tap water here. We actually have turtle tank water, which is actually pretty good. And we actually have Camden tap water. And we have Pine Point water sample. You see that? Now that's groundwater. That's the difference between groundwater and tap water. You see that? Tap water is coming from our faucets, which is already filtered. See that? You don't see anything in there, no type of debris. It's nice and filtered. Now, groundwater is coming from the ground, pure out the environment, whether it has trees or dirt, it's coming straight from that water. You see that? It's a little bit different brown. You see some dirt at the bottom. That is the difference between groundwater and tap water. This one's filtered and this one is not filtered.
So what you're saying is that the tap water we can drink and the groundwater we cannot drink?
Yes, you can definitely drink the tap water because it's already filtered, and you cannot drink groundwater. I repeat, cannot drink groundwater.
Or we'll get sick, right?
Yes, most definitely.
Yeah.
So that's basically what we're going to do, our experiment. We're going to see what the pH scale is for the water, and for the groundwater. And also the temperature. So let's get started, shall we? All right. So first we're gonna pour our samples, or 2 samples in here. So this sample will be, I'm gonna take it up a little bit. This sample will be our groundwater. And this sample will be our regular normal tap water. And this sample will also be our turtle tank water, which we'll see what will happen or what it's going to look like, what animals live in that environment or in the water. All righty. We're going to label these so there's no confusion. So you could just put GW for groundwater. And then I'll put TW for tap water. And then you can put, because I know TW, we can't have 2 TWs. I'll put turtle. All right, we got our 3 samples. How about we do something simple? We're gonna check the temperature first.
So this is our thermometer. Can everybody see the thermometer?
You can give us a big thumbs up if you can see it.
Yes, and I believe this is in Celsius. In America, we use Fahrenheit, but today we'll just be using Celsius. So I'll measure the groundwater first.
Get that few seconds, see what's the temperature looking like for the groundwater.
Can we have any guesses on what temperature you think groundwater is? So outside, think of outside. Is it hot? Is it cold?
I'd say it's fall,
I think it's hot.
but at the same time, it could be cold because it's
Yeah, I think it's cold. All right. So let's see. What's the temperature looking like, Miss Jelly?
Right now, the weather in Camden is 88 degrees Fahrenheit.
And the temperature is looking like, I would say about
19?
19.
Okay. I'll convert that into Fahrenheit. So the temperature of the water in Fahrenheit is 66 degrees.
Whoa.
Kind of low for the groundwater, but it's okay. So, all right, we got 66. Let's dry this off. All right, next we're gonna be testing the tap water.
But before we say anything, what do you think the temperature for the tap water is?
Feel free to unmute. What do you think the temperature of the tap water is? Is it gonna be cold or is it gonna be hot?
You can just shout it out.
Or you could just say,
Don't be shy.
it's okay.
It's okay.
You can either raise your hand for hot or put a thumbs up for cold.
So raise your hand if it's hot, if you think it's hot, or thumbs up if it's cold.
All right, we got one cold.
One cold. Brian, what do you think? Okay.
All right, so we got one cold. Let's see. It's 18 in Celsius, but we're gonna convert that into Fahrenheit, and that would be 64 degrees in Fahrenheit. So that's actually a little bit more warmer than the groundwater. So okay, so it's actually warmer. So now we're gonna test the turtle water. All right.
Any guesses for the turtle water?
You think, raise your hand for hot, thumbs up for cold. All right, we got another cold. All right, let's see. All right, give a little bit. So it's 15. So whoever said colder, you are correct. So let's convert that into Fahrenheit. It's actually 59 degrees. So this is actually colder. So was actually the coldest. So the turtle water was actually the coldest water. Then the groundwater and the tap. So that goes to show you can also measure the water as well. You can do this with any water. You can go into your sink and grab a thermometer and see how cold or hot your water is actually. All right, and our next test, we're going to be testing nitrates.
Does anybody remember what nitrates are? Or what makes up nitrates? No. So let's remember that Ms. Nam here explained that nitrates is a compound of both nitrogen and oxygen, right? So it's blue and red.
So what I'm doing is we have our little test tubes here. Our 3 test tubes that we're going to put our water samples in, and we're going to grab our droplets. All right, so I'm going to hand Miss Jilly and Miss Jasmine a pipette so they can put it into our little tubes. And you see here, we have specific instructions so we can make sure that we are following those directions so we can get the best results. So it's telling us to fill up our tube to 5
Milliliters?
Yep, milliliters. So we're gonna be filling up all the way up to that line. Right there. All right. And then we have our nitrate tablets that we're gonna be putting in. We're gonna put in exactly 1 tablet.
These are what the tablets look like in the packaging, right? And then we take them out,
Thank you.
they look like that.
Now, we do not put these in our mouths.
That would be that.
No, that would be very bad. This is only for the water, but that's what nitrate tablets look like. So we're gonna put these in the water, like so. And you see that? So all the way, you see those bubbles? So that's actually dissolving into the water. We're gonna seal them up. And then what we're gonna do is we're gonna do this motion, this back and forth motion. So the nitrate tablet can dissolve fully. So we're gonna keep doing this back and forth motion, and so. And as you can see, you might see the water changing colors, like a little bit of a whitish color. That is perfectly normal. So something like that. You see how that water changed from clear to a little bit of a darkish color, a little bit like a dull white. All right, so now that our tablet is fully dissolved, like so, we are going to move on to the second step. We're going to use the second type of nitrate tablet. We're only going to put 1. And then we're going to do the same thing how we did for the first tablet. Thank you, Miss Shirley.
No problem.
All right, and we're back to mixing again. See that pill moving up and down? And we're gonna set a timer for 2 minutes. See, so the tablet can fully dissolve. And now you see that the water is kind of turning a little bit of a yellowish color. That's cool. That's how you know the tablet is working. See that? Nice and a little yellowish here. So we're gonna keep mixing it until it's fully dissolved. See, look at Miss Julius. I know she has the groundwater. See, that's what's happening to the groundwater with the nitrate pills. You see how it's turned to a darker yellow? Yeah, look at that. So this is the tap water, and that's the turtle water. There's 3 different shades of yellow here. That's pretty cool.
We have about a minute left.
Yep.
Bear with us, please.
And then afterwards, we're gonna put these to the side and run another test. We're gonna do pH because we have to wait 5 minutes until we move the top of the tablet, the top of the tubes, to make sure that it's fully, mixed and well, and that the chemical in there is working with the water, so we can see the test clearly.
About 20 more seconds left.
We're gonna mix. See how it's still a little bit yellow? Let's see Miss Shirley's, if it changed. Yeah, look at that. This one's a little bit clearer. The tap water is clear, but the groundwater is a little bit darker.
Yeah.
Let's compare it to the turtle water as well. So, yeah, the turtle water is actually clearer than the groundwater. All right, and we're done. So we're gonna put these to the side for 5 minutes. So we can put them right here. All right, and then we're gonna start our pH test. There we are. So this is what our pH test is looking like.
Does anyone remember what pH is?
Well, we actually didn't go over that quite yet, so this is pretty new. So this is actually our pH chemical. Bit dark and green. And this is going to be the scale that we're measuring it from. So what pH is, as you see on the scale, is to test how acidic or basic something is. So we're testing how acidic the water is or how basic it is. So you see how it's kind of like that green? That's actually the pH chemical that we're going to use. So first, we're going to grab some of the water samples, how we did earlier. Of course, I'm going to put this. We're going to put it this time to 10, all the way up at the top. All the way up to the top. All right. And next, we're going to add 10 droplets of the pH. All right, let's see. So we got to be nice and careful with this so we can get the exact measurement. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See that it's kind of green. So it's not going to be green now. It might change. And then what I'm going to do is I'm going to put the cap on it gently. And then I'm going to do that same mixing motion how I did with the nitrate. You see that? That green, so it's going to mix in. Look at that pretty color. A nice lime color with the green. Gonna mix it. Okay.
I've also added the green drops to mine,
To the groundwater. And
to the turtle water.
oh, look at that. Turtle water's looking kind of different. See that different shade of green? It's actually a little bit more like darker. And the groundwater is actually a little bit of a yellowish green. Wow, you see the difference in that? It's pretty cool. So you see different results so far. All right. All right, and then next, we're gonna take our scale here and we're gonna put in our tubes in here. All right. So Miss Jelly, if you could put your test tube in so we can see what that scale is looking like. So what do you think? You think it looks like it could be 7 or 7.5? I think it could be, you think a 7?
I think a 7.
A 7? Right on 7?
Yeah, right.
Well, actually, that is 7 is actually the neutral number. So it's actually right in the middle. So the groundwater is actually neutral. Wow, I would never believe it. So that's actually a really good thing, which means whatever is happening in that environment in the groundwater, actually the Pine Point groundwater, is actually doing good. So we're gonna write that down, that it's 7. So pH for the Pine Point water is exactly 7, which is neutral. So that environment is doing really good. Nothing wrong. The water is just fine. So we're gonna put that to the side. And next we have our Philly tap water. So let's see what that's looking like. Looks like a close call. It kind of looks like it could be 7.5.
Yeah, I believe it's
7.5.
What do you guys think?
You think it's 7.5? Put a thumbs up if you think it's 7.5, or put a hands up if you think it's something different. So we got one that's 7.5.
Okay, what about you, Brian? What do you think?
I think it's 7.
Think 7? Yeah, that's pretty cool. 7.
Yeah, they do kind of tie closely together.
Yeah, they do. So I think it will be in the 0.5 range.
0.5?
Because, now it's a little bit off of the neutral side, but it's close to it. That's still really good. That's still pretty good. Now we want the water, especially for tap water, to be close to the neutral because that's kind of telling us it's also safe to drink as well. Next, we have our turtle water.
That is very green.
Yes, it is. It's very green, but not too green though. So, I don't think it looks like 7.
Like 8.
You think it looks like 8?
I think it looks like.
Who think it looks like 8? in the
Raise your
8
hand
range?
if you think it looks like 8.
Or mute if you think it looks like 8. I think it looks like 8. Look at that green. Nice lime green.
So you can raise your hand if you think that it's 8. Or if you think it's something that, okay, so Brian thinks it's 8.
Brian think it's 8? I think you're right, Brian. It is 8.
Yeah.
Yeah, right near that range. Now, for animals and what they're as far as like with turtles, kind of a bit different with their pH scale because they're animals and of course they use the restroom in there and they eat in the tank. So it's okay if it's not 7 because it's not actually the water you should be drinking. So I would consider this to be healthy water. Nice where it should be. As long as it's not like purple, then we're in a good range. That means the whatever water those turtles are in, they're living nice and healthy. So good for those turtles. All right. I think it's time for the nitrates. All right, I think our 5 minutes is up. So we can go back, grab that nitrates kit. We're gonna put up our pH to make sure all the materials are back in there. There we go.
Yes, it is very important to stay organized when dealing with chemicals.
Yes, very important. It's also very important to follow each instructions to get the best results.
Yep.
And my, oh my, you remember, I'll give you a quick flashback that the colors were yellow, but they were different shades of yellow. Oh boy, they definitely changed. Okay, so we're gonna bring out our scale here, our nitrate scale.
It looks very similar to the pH scale, doesn't it?
Yep, but their scale, the nitrate scale is on the pink side, so you can see how pink it is, or closer to that.
Yep.
All right, so can't you believe? So actually our groundwater kind of stayed the same, but a little bit of a darker yellow.
So put it.
And our tap water is a huge difference. You see that? This is the groundwater and this is the tap water. Tap water is kind of looking a little pink. And next we have the turtle water. It's kind of a lighter pink than the tap water. But that's kind of cool. They actually have pink change. So let's test that. So Miss Jelly, if you can put the groundwater into the scale. All right. So I would think, what do you think?
I think it's looking like a 0.0.
0.0?
What do you guys think?
You think it's a 0.0 or a 1?
Unmute yourself if you think it's a 0.0.
0.01.
Or raise your hand if you think it's a 0.0.
Or put a thumbs up if you think it's a 1. Oh, All right, so we got a 0.0. All right.
What about you, Brian? What do you think? You think it's a 0.02?
Yeah, I think it's a 0.0. How about you, Miss
Yeah.
Jasmine? You think it's 0.0?
Yep.
Yep. Yep. So 0.0, that's actually pretty good for groundwater. Wow, this groundwater actually, it's neutral with the pH, and then we have 0.0 with nitrates. So the nitrate level is pretty good. That's okay if it's a little bit one nitrates because it is providing, again, nutrients and plants for plants. As long as it's not looking like, I would say like a 15, on the scale, or a 10, or anything probably like a 4 and down, because that would mean that the groundwater from the pine point is actually starting to, with the algae bloom process, which is kind of dangerous. So this water is kind of looking healthy. Wow, I'm surprised. And now we have our tap water from Philly. Let's see, of course, it looks a little bit pinkish from the Pine Point water. Ooh, that is a nice, I think that would be falling under 4.0. 4.0 is kind of a little darker. I think it's a 2. So put your thumbs up if you think it's a 2, or raise your hand if you think it's a 4. So this is 2 over here, and this is 4.
So we have a thumbs up for 2.
Thumbs up for 2. Thumbs up for 2. Totally, I agree. Thumbs up for 2. So that is, it's all right. Now, sometimes it's okay if, well, you got to be careful because with tap water, if it's a little bit darker. Now, of course, pipes in our sinks that's running from our kitchen sinks, bathroom sinks, you may get some chemicals from the pipes in there since it's either plastic or metal. So that's coming from probably the plastic or metal of the house. It's fine. As long as it's not darker than, a 6 or a 4 or 8, then it'll be a little bit on the concerning side. Then you might have to leave the water running on for a little bit to check if to make sure all the toxins can run out of the water. So that's looking pretty good. And next we have our turtle tank water. Now this is the big test because you remember like the scene from Nemo, we don't want this water to be too dark. That means that it's starting to begin the process of algae bloom. That's dangerous. So, okay. I think it's looking between a 1 or a 2.
Yeah.
You think so too, Miss Johnson, a 1 or a 2?
I'd say a 1.
A 1?
Yeah.
So put your thumbs up if you think it's 1, or put a hand or raise your hand for 2.
Thumbs up for 1. Raise hand for 2.
Thumbs up for
Okay, we got a 1.
1. All right. All right. I think it's 1 too. Yep. Definitely in the 1 range. So that's really good for turtles too, for those turtles living in that water. That means that they're perfectly fine. And probably the reason why it's so dark is because, they use the restroom and all their, their urine and their poop is kind of like a little bit raising the scale of the water. So that's perfectly fine. So that's good. So their water is also healthy as well. Wow. I think we have one more test, and it's actually the salinity test, which is the salt. So we're going to see if the water is at its normal salt range. So this is what a salinity, a hydrometer is called. Hydrometer, that's what we call this tool used to test how much salt is in the water. So I'm going to put these two up. And then we're going to bring the groundwater from Pine Point and see what the salt is looking like. I'm going to dip it in. And since it's fresh water, it should be below 1.
We should also remember that salinity, the unit of measure, is parts per million, per thousand.
Yep, PPT, parts per thousand. And I also want to show you all another tool. It's a big word. It's called the refractometer. It's a bit of a tongue twister. But this is also another tool. And what we do is, just in case of this one, it doesn't really show really a good result, you flip the top up carefully. And then what we're gonna do, we're gonna put a pipette in and we're gonna suck some of the water, add a little bit of the sample, and then flip this cap. It's gonna make it flat. And then you see this lens, almost like a telescope mixed with it. We're gonna hold it up to the light, and then we look through the lens. It's gonna be a little meter inside, and it will tell us what is the parts per thousand of the water, how salty it is. Or if it's less salty. So we're gonna test that as well. So just how I said, we're gonna grab our water sample, not too much, just a little bit. Put like 1, 2 drops, probably 3 in there. And then we're gonna close it. You see how flattened that's there? Right, that water flat right there. And then I'm gonna look through it where the light is at. And believe it or not, it's actually close to, yep, it's actually kind of close to 0. So it's a little bit less, which is kind of good. It's really less than 1. So I wish you guys can see it because it's kind of a little hard because the lenses are different, but that's how you would test it. And you always got to make sure when you're using these type of tools, you make sure you be nice and delicate with it. Dry it off, and then good. So you can write down here that it is less than 1. Now let's see how this one's doing. So this one's saying that it's on like, or this one saying like it's near 20, 21 or 22. That's a bit, that's the temperature. So this is the temperature and this is the salt range. So it's saying it's 1.03. So we can say 1, close to 1. So that one's saying 1, this one's saying less than 1. So it's kind of in between. So I would say it's pretty good range. This one. Well, pretty good range for the groundwater, since for freshwater it's less than 1. So now the real question is, let's test the tap water from Philly. So of course we're going to use the hydrometer. Going to take a little sample of this. Right. Nice and flat. It's nice and in there. Gonna look at it. This one too. That white line is barely towards 0, so it doesn't have salt in it. Which kind of makes sense because if you would taste the tap water, you would taste like a salty taste to it. And this one, of course, just regular normal water, no salt in it. So that will be near 0.
So this is near 0?
Actually, it's actually 0.
0?
Yep. This one. This one's saying 1 is the same 1. Now, I don't think that's really true because then we will taste a little bit of it, but kind of debatable. We could put 1 on there too. Because even though it is tap water, you might, like again, how I said, you might get a little bit from the pipes. So 1. But I would say this one is mainly 0 because you really don't taste the salt. So, all right. Put that to the side. That was a tap water from Philly. And then next, we are going to use the turtle water. Okay, to do this one, Mr. Allen? Yep, just put it in. And then what you're gonna do, now take this pipette right here, open the lid, take some of the water, make sure not too much, and 1 or 2 drops. Yep. Just like that, that's good. And then flip it over. Bam. Now what you're gonna do is you're gonna hold it to the light. So now she's gonna hold it to the light so she can see it. And it should be like a white little meter to tell you where it's at. So how's that turtle tank water? Middle of 1?
Like
Yep.
1.5.
You wanna see, Miss Julie?
Oh, yeah.
Right near 1, right?
Yeah, I'd say it's like exactly at 1.
Exactly at 1. So that's pretty good. So exactly at 1, You're not living in salty water because, you know, the turtles, and they really don't really need salty water because, of course, even though they're semi-aquatic, depending on what type of turtle that is, they live in more of a freshwater range, not really in brackish water that much. So all these waters are looking nice, really nice. I'm really surprised with the groundwater because since it's natural water, it's actually have a neutral type of water for the pH. The nitrates, no type of nitrates, so the animals are living healthy, and the salinity levels are where it should be for freshwater, less than 1. The tap water looking great from Philly, a little bit probably with the nitrate levels and from the pH. We can't always have perfect water, so there might be from the pipes, but it's still good. And the turtle water absolutely looking good. So those animals are thriving in the water. So that was our activity, which was called Brown versus Tap. And I hope you really learned something from it and enjoy it. So that was really great. So I think we are going to move on for the droplet of the day. So I hope you'll enjoy this activity, and we're going to move on to the droplet of the day. Enjoy.
Hello, everybody. How was that? Was it fun? Was it interesting? I think it was good. I love the nitrate part. Okay, so for the droplet of the day, it is the question, and then we're going to take a 2-minute break. And then when we come back, we'll answer the question with you guys. So the question is there water on the moon? Is there water on the moon? Do we think there's water on the moon? What do we think? We'll come back 15 minutes and we'll answer the question with you all. Any guesses? Is there water on the moon?
We put a lot of thought to it. You can always type in the chat your answer. You can always unmute yourself. Feel free to type in the chat if you want for the answer.
Any guesses?
I'd like to believe there's water on the moon, but I don't really know.
Now one guess. Ryan, are you there? What do you think?
The question was again, is there water on the moon? You can always type in the chat.
I didn't think there's water on the moon because if there was water on the moon, we would have taken it.
So you think there isn't water on the moon?
Yeah, I don't think there's water on the moon.
Okay. Well, is that it? Is that everybody? I think that's everybody. Okay. Well, the answer to the question is there is water on the moon.
Oh my God.
Yes, NASA scientists have found water on the moon in the form of ice.
Believe it or not, it's hard to believe. I don't know.
Yep. And I'm pretty sure they found water in Mars as well. Yeah, Mars. I believe it's Mars. Yeah, we're finding water on different planets, which like brings up the question like, is there a civilization on the planet? We don't know. So yes, there is water on the moon, but it is in the form of ice, so it's not like you can drink it.